Imagine a place in the cosmos where the very fabric of reality unravels, where our most trusted laws of nature falter, and where certainty dissolves into a bizarre realm of paradox. This is no distant science fiction dream, but the unnerving truth about black holes, a phenomenon so extreme, so fundamentally strange, that they seem to mock the way we understand the universe itself. Think about it. Every time we peer into the abyss of a black hole, we confront a puzzle that physics cannot fully solve, a cosmic enigma that demands us to rethink everything, down to the mysterious core of existence. What if the boundaries of space and time are not as solid as we once believed? Black holes force us to ask questions that unsettle the heart of scientific certainty. Inside these invisible giants, our predictions crumble. Time slows down, space twists, and matter is crushed to conditions beyond comprehension, suggesting a place where gravity becomes irresistible, yet simultaneously where our physical laws appear to break apart. Yet somehow, these realms are not just theoretical constructs. They tug at the edges of reality, pulling us toward the ultimate cosmic contradiction. How can something obey the laws of physics and break them at the same time? Consider the singularity, the enigmatic center of a black hole. It is not simply a point but a cosmic paradox, a cauldron where density spikes toward infinity and the concepts of distance and time lose their meaning. But what does infinity really signify? In mathematics, infinity can be a powerful abstraction, but in physics, it is a signal, an admission that our current theories are incomplete. The singularity is where general relativity, Einstein's crowning achievement describing gravity, collapses into incoherence, revealing cracks in the grand edifice of spacetime itself. But here's the marvel: rather than signaling an endpoint, this breakdown invites a new frontier of discovery, an uncharted landscape where quantum mechanics and gravity must finally reconcile. Until that happens, black holes remain the ultimate riddle, a warning etched in the fabric of the cosmos that our understanding is unfinished. Yet, the mystery deepens when we dive further into black hole thermodynamics. These cosmic shadows emit faint radiation, Hawking radiation, a quantum whisper that slowly erases them from existence. This insight was revolutionary, proving that black holes are not eternal prisons but dynamic players in the energy economy of the universe. However, it also upends a foundational belief: the loss of information. According to classical physics, anything swallowed by a black hole disappears irretrievably, yet quantum theory insists information cannot be destroyed. This profound contradiction, often called the information paradox, is far more than theoretical hairsplitting. It's a challenge to the very nature of reality, a puzzle that has engaged the brightest minds for decades and one that still resists resolution. And what if black holes hold clues beyond physics to the origins of the universe, the nature of consciousness, or dimensions we have yet to imagine? With every discovery, black holes feel less like isolated oddities and more like profound gateways to the unknown. They embody the tension between what we know and what we can only guess at, between the measurable and the mysterious. They are cosmic invitations to humility, reminding us that the universe, vast and ancient, guards secrets that stretch far beyond the confines of human logic. As we embark on this journey to uncover why black holes seem to break physics, we step into a tale woven from the threads of mystery, brilliance, and the unyielding human desire to understand the cosmos. The story we are about to unravel is not just about astrophysics, it is a quest to confront the limits of knowledge itself. Are we ready to peer beyond the veil and explore where the laws of nature fade into the unknown? The abyss awaits. To understand why black holes challenge the very foundations of physics, we must first venture into the realm where our understanding begins to fray, the marriage of gravity and quantum mechanics, two pillars of science that stubbornly resist unification. Imagine the universe as a grand stage, where particles and forces perform a ballet choreographed by the laws of physics. Gravity governs the sweep of galaxies and the arc of planets, described elegantly by Einstein's general theory of relativity. At the smallest scales, quantum mechanics rules the behavior of the infinitesimal, dictating the dance of atoms and photons with equal precision. Yet, when these two places converge near a black hole's event horizon, the boundary beyond which nothing escapes, conventional physics falters. Einstein's equations tell us that inside a black hole, gravity's pull becomes infinite, warping space and time into a singularity where known laws collapse. But quantum mechanics refuses to let go of the certainty it promises, insisting that particles and their information cannot vanish without a trace. The conundrum arises because the singularity's heart is a place where both gravitational warping and quantum uncertainty intensify beyond endurance. Here, space and time as we know them break down, leaving us with an uncharted frontier where our concepts of reality lose their footing. This tension is not merely academic, it forces us to question the architecture of the cosmos at its deepest level. Black holes expose a fundamental flaw in our current frameworks, implying that neither Einstein's continuum of smooth spacetime nor the discrete probabilities of quantum mechanics can fully describe what unfolds within these cosmic giants. They are the stress test of physics, highlighting where our theories are approximate sketches rather than complete portraits. Consider, for instance, the strange phenomenon of Hawking radiation, particles that seemingly emanate from the very edge of the black hole's abyss, like whispers escaping a sealed chamber. This radiation hints at a delicate dance between the vacuum of space and the intense gravitational fields surrounding the black hole, a phenomenon that only arises when quantum effects mingle with the gravitational pull. It's a glimpse into a reality where empty space isn't empty at all, but a seething froth of particle-antiparticle pairs that reveal the blurred boundaries between matter, energy, and spacetime. Yet, even this insight brings us no closer to a definitive answer. If black holes evaporate over time through Hawking radiation, what happens to the information about the matter they consumed? Does it dissipate into chaos, or is it somehow encoded on the black hole's surface, as some theories suggest through the holographic principle? This idea proposes a radical reframing of space itself, that the three-dimensional world we inhabit might be a projection of information inscribed on a distant two-dimensional surface. If true, it would rewrite our understanding of dimensions and suggest a universe far stranger than our senses betray. This cosmic puzzle is further deepened when we explore the notion that black holes might harbor firewalls, zones of intense energy that could incinerate anything falling through the horizon, defying Einstein's principle that crossing the event horizon should be uneventful. The firewall hypothesis arises from attempts to reconcile quantum mechanics with gravity but raises uncomfortable contradictions, pitting physical intuition against mathematical necessity. This clash between conflicting truths challenges us to rethink some of the most sacred assumptions in physics, like the smoothness of spacetime and the unity of physical laws. Moreover, black holes compel us to revisit the nature of time itself. Within their depths, time dilates to extremes, slowing almost to a halt compared to an outside observer. Yet, at the singularity, time as a dimension loses meaning entirely. Could black holes be windows into alternate temporal realities or even the seeds of new universes? Some speculative theories propose that what we perceive as singularities might be bridges, wormholes, that connect different regions of spacetime, or gateways to realms beyond our cosmic horizon. While still conjecture, these ideas ignite the imagination and hint at the broader implications of the contradictions black holes embody. In peeling back these layers, black holes become more than astrophysical oddities, they transform into crucibles where the most profound questions of existence are distilled. They force us to reconsider mysteries not only about matter and energy but about the very fabric of reality, the flow of time, and the limits of human comprehension. Every discovery around black holes brings us face to face with the edges of knowledge, reminding us that the universe is not a solved riddle but an unfolding enigma. Thus, as we stand on this threshold, pondering the secrets locked within these dark giants, we embrace a humbling truth: black holes don't just break physics, they shatter the illusions of certainty and invite us to imagine a cosmos where the rules themselves are in flux. The stage is set not merely for new science, but for a revolution in how we perceive reality. In this place of shadow and paradox, our greatest challenge and opportunity awaits. To understand why black holes break physics, we must first confront the very equations that describe the cosmos, Einstein's general relativity and quantum mechanics. These two monumental pillars each offer profound insights into the universe, yet when forced to coexist at the heart of a black hole, they reveal cracks in the foundation of our understanding. General relativity elegantly explains gravity as the warping of spacetime by mass and energy. It predicts the existence of black holes as regions where gravity becomes so intense that nothing, not even light, can escape. The math leads inexorably to a singularity, a point of infinite density and zero volume, where the known laws of physics cease to operate. But this singularity is where the theory itself collapses. Infinity signals not a concrete physical reality, but a breakdown, a place where our current mathematical tools cannot reach. On the other side, quantum mechanics governs the microscopic realm, where particles fluctuate and probabilities dictate outcomes. It champions uncertainty rather than absolutes, painting a picture of reality that is fundamentally discrete and probabilistic. Yet, when quantum laws are applied near or within a black hole's event horizon, they clash with the smooth curvature of spacetime that relativity demands. The main theory at the crossroads of this conflict is the quest for a quantum theory of gravity, a unified framework that can reconcile these seemingly incompatible views. One of the leading candidates is string theory, which replaces point particles with tiny vibrating strings, hinting at hidden dimensions beyond our perception. Another is loop quantum gravity, which suggests that spacetime itself has a granular structure, composed of indivisible loops woven into a cosmic fabric. Through these lenses, a black hole is no longer a mysterious pit but a complex quantum object, whose surface encodes information about everything that has fallen inside. This idea is encapsulated in the holographic principle, a radical proposal that the three-dimensional interior of a black hole might be described entirely by information encoded on its two-dimensional boundary. If true, this challenges our deepest intuitions about space and volume, turning the notion of insight on its head. Yet even this promising insight leads to paradoxes. The black hole information paradox highlights an apparent contradiction. Quantum mechanics insists that information cannot be destroyed, but classical black hole theory implies that anything crossing the event horizon is irretrievably lost. Resolving this paradox requires reimagining the principles of quantum mechanics, gravity, or perhaps both. Recent theoretical breakthroughs suggest that black holes may not be the smooth, featureless entities once imagined. Instead, their event horizons might be seething with quantum activity, giving rise to what physicists call firewalls, infinitely energetic barriers that burn up anything attempting to cross. This concept shatters the elegant simplicity of Einstein's event horizon, forcing us to rethink the very anatomy of space around black holes. Another compelling hypothesis arises from the concept of entanglement, the quantum phenomenon that Albert Einstein famously dubbed spooky action at a distance. Some physicists propose that the fabric of space itself emerges from the entanglement between particles. If so, black holes might represent zones where this entanglement breaks down or is radically reorganized, destroying the classical continuum of spacetime. In a related vein, some researchers explore the notion that black holes are not isolated objects but deeply connected to the universe through a vast network of quantum correlations. This interconnectedness implies that information swallowed by a black hole might not be lost but subtly copied or mirrored onto distant regions of space, preserving a cosmic ledger in a form we have yet to decode. These ideas do not merely deepen the enigma, they raise profound philosophical questions about the nature of reality. How can something be both locally destroyed and globally preserved? What does it mean for space, time, and information to intertwine so tightly that unraveling one thread alters the fabric of the whole? Black holes thus become the ultimate testing ground for the interplay between determinism and randomness, locality and non-locality, and the very architecture of the cosmos. The implications spread beyond theoretical musings. If a functioning quantum theory of gravity emerges from these studies, it could unlock new realms of physics, revealing insights into the earliest moments of the Big Bang, the behavior of neutron stars, and even the possible destiny of our universe. It may usher in a new technological age, where harnessing extreme gravitational phenomena becomes plausible. Yet, amid the excitement, there remains a humbling recognition: black holes expose the limits of human understanding. Our best mathematical models run aground on their shores, signaling not failure but opportunity. They invite us to transcend established paradigms, to embrace a cosmos far stranger and more wondrous than ever imagined. In the shadows where gravity and quantum quirks collide, black holes stand as silent provocateurs. They challenge the notion that the universe is comprehensible within tidy equations and predictable rules. Instead, they reveal a dynamic canvas where knowledge is provisional, and certainty is fleeting. Thus, the theory of why black holes break physics is not a dead end but a doorway leading us toward a deeper synthesis of the universe's most fundamental principles. It is a story still being written, where each new insight kindles fresh mysteries, and the black hole transforms from a cosmic enigma into a symbol of the universe's unfolding, unapologetic complexity. In standing at the edge of this mystery, we confront not just the vastness of space but the vastness within ourselves, the human yearning to understand, to explore, and to reach beyond the frontier where physics as we know it dissolves into the unknown. It is here, in this liminal space between knowledge and imagination, that the true nature of black holes, and perhaps reality itself, awaits revelation. Beyond the veil of these cosmic titans, black holes unsettle more than just the laws of physics, they strain our very conception of reality. When we peer into the heart of a black hole, gravity intensifies to such extremes that the smooth fabric of spacetime, as depicted by Einstein, distorts into something unrecognizable. Here, classical physics no longer offers a reliable map. It's as if the universe, in its most extreme form, bends the rules it once wrote for itself. But the real tension arises when quantum mechanics, the theory governing the subatomic world, steps into this gravitational theater. Inside a black hole's event horizon, an impenetrable boundary, quantum uncertainty and spacetime curvature collide in a profound paradox. This is where singularities, points of infinite density, emerge in calculations, signaling that our foundational theories fracture against the backdrop of these cosmic abysses. Singularities represent the breakdown of our mathematical models. They are the universe's cryptic signatures, indicating missing chapters in the laws of physics. To understand these phenomena, scientists have begun exploring fresh perspectives that merge gravity with quantum principles. One compelling avenue involves holography, a concept suggesting the information within a three-dimensional volume could be encoded on its two-dimensional boundary. Remarkably, black holes seem to behave like cosmic hard drives, where information about everything swallowed is somehow preserved on their surface, a notion encapsulated in the holographic principle. This leads to perplexing questions. If information is never truly lost inside a black hole, how does it escape the seemingly irreversible event horizon? This puzzle, known as the black hole information paradox, is a central challenge pushing scientists to rethink the foundations of quantum theory and gravity. Moreover, recent observations hint at the fascinating role of entanglement in black hole physics. Quantum entanglement, where particles become linked across vast distances, may be entwined with the very structure of spacetime. Some theorists propose that spacetime itself emerges from a vast network of entangled quantum bits, suggesting black holes are not merely gravitational pits but gateways revealing the hidden quantum scaffolding of the cosmos. If true, black holes might provide a unique laboratory to decode how space and time, dimensions we take for granted, arise from fundamental quantum processes. Astronomical evidence also points to unexpected complexities. For instance, the shadow of the supermassive black hole in the galaxy M87, captured by the Event Horizon Telescope, revealed subtle distortions hinting at phenomena unexplained by current models. These observations compel us to ponder whether new physics lurk beyond Einstein's framework, perhaps involving extra dimensions or exotic particle fields interacting in the black hole's vicinity. In peeling back these layers, black holes emerge as paradoxical symbols. They are both erasers of information and archivists, destroyers of matter and builders of exotic quantum landscapes. The quest to reconcile this duality has led to speculative theories exploring wormholes, where black holes act as portals linking distant regions of spacetime, or even to the tantalizing suggestion that our entire universe could reside inside a colossal black hole within a higher dimensional reality. Yet, amid such grand conjectures, the core lesson remains anchored in humility. Black holes reveal a frontier of physics where certainty dissolves, and theories that once seemed absolute become provisional. They beckon us not toward simple answers but toward a deeper, more nuanced understanding of nature's fabric, one that embraces mystery and complexity as intrinsic features, not inconvenient anomalies. In this scientific expansion, black holes transition from mere cosmic oddities into catalysts for revolution, inspiring generations of thinkers to craft novel frameworks that marry the quantum and the cosmic. Each insight, every breakthrough, nudges us closer to glimpsing the ultimate blueprint of reality, a blueprint where the mysteries once breaking physics may instead be the keys unlocking it. Through this lens, the enigmatic breakdowns near black holes make sense not as failures of science, but as signposts to new realms of knowledge. They remind us that the pursuit of understanding is an unfolding journey, where each black hole is less an end and more an invitation, a celestial whisper urging us to rethink the very foundations of existence, and in doing so, to redefine what it means to comprehend the universe itself. So, what does it mean that black holes shatter the very laws we've trusted to describe our universe? Beyond academic curiosity or mathematical curiosity lies a question that touches on the nature of reality itself. How can something so simple, a celestial object defined by mass, spin, and charge, challenge our deepest notions of truth, existence, and even consciousness? Imagine, for a moment, the boundary of a black hole not as a physical line, but as a philosophical veil. Here, our familiar concepts, cause and effect, time's unidirectional flow, the separateness of observer and observed, all unravel. The singularity at the heart of a black hole is a place where classical physics curves violently toward infinity, yet paradoxically, it's also where our senses and instruments fail completely. In a way, it is the ultimate unknown, a void that cannot be measured but insists on altering the fabric of space and time around it. This boundary challenges the very act of observation, raising profound questions about consciousness. If all information about the matter swallowed is scrambled or erased, does reality itself become subjective, depending on the observer's perspective? This cosmic boundary triggers a reframing of the observer's role in the universe. Not unlike the philosophical reflections inspired centuries ago by thinkers wrestling with the puzzles of perception and being, black holes compel us to reconsider what it means to witness an event, or to know something is real. They draw an eerie parallel to the well-known quantum conundrum that particles exist differently when they are observed. What if the universe around a black hole operates under a similar yet magnified principle? Could it be that the laws of physics and reality itself are entwined not only with hard matter but with the act of conscious observation, interlinking cosmic phenomena with the very experience of awareness? The implications ripple outward into the realm of existential meaning. If black holes mark domains where spacetime and causal order break down, where the ticking of clocks stops making sense, then they also symbolize the limits of human understanding, the boundaries of what can be known, predicted, or controlled. They exist as silent reminders of our cosmic humility, that the universe is not a mechanical clockwork finely tuned for our comprehension, but a realm of seductive mysteries, where paradoxes are woven into the fabric of existence. In facing these enigmas, humankind confronts not only cosmic puzzles but also the profound mystery of its own place in the cosmos. Are we mere bystanders circling these celestial strangers, or co-creators of reality, whose consciousness is intertwined with the universe's deepest structures? Even more haunting is the sense that black holes evoke a kind of cosmic darkness beyond physical obliteration, a metaphor for the ultimate existential unknown. Where light disappears and information seems irrevocably lost, we glimpse the shadow of mortality writ large upon the universe itself. Yet in that darkness, there is also a paradoxical potential, the black hole as a crucible for transformation, for a redefinition of existence beyond classical constraints. They challenge the distinction between life and death, origin and end, presence and absence. In their mystery, black holes invite a kind of philosophical reverence, a meditation on impermanence and the unseen forces that shape reality. As we probe their depths, black holes call into question the very foundation of objective reality. The fabric of spacetime, and with it, the frame in which events unfold, is no longer an immutable stage but a dynamic entity that bends and contorts, reflecting the intimate interplay of matter, energy, and possibly even consciousness. This dynamic suggests a universe far more fluid and interdependent than classical frameworks ever allowed. It nudges us toward a worldview where the observer and the cosmos are bound in a delicate dance, where the laws of physics are not just external decrees but expressions of an underlying unity that defies simple categories. In embracing this new vision, black holes become more than scientific curiosities or enigmatic endpoints. They emerge as symbols of transformation, spaces in which the rigid boundaries between knowledge and mystery, existence and non-existence, order and chaos begin to blur. They silence the comfort we find in certainty and beckon us to a contemplative space where the questions matter more than the answers. And in that surrender, in facing the unknowable, we touch on something profoundly human, the restless quest for meaning amid the vast and often silent cosmos. Ultimately, black holes compel us to look inward as much as outward, to consider not only the cosmic canvas but the lens through which we perceive it. They reveal that physics, no matter how elegant or precise, is incomplete without a reckoning with consciousness and meaning. Perhaps in this lies the true legacy of black holes, their ability to shatter the physics we know is matched only by their power to expand our understanding of what it means to be a thinking, feeling presence in an ever-changing universe. The mysteries they pose are an echo of our own inner depths, and as we strive to unravel them, we embark on a journey as much philosophical as scientific, a journey toward the very heart of existence itself. Beneath the swirling chaos of a black hole's edge lies a realm not just unknown, but fundamentally unknowable, a place where our most trusted theories collapse under the weight of their own contradictions. Yet it's here, in this shrouded domain beyond the event horizon, that the universe may be hiding some of its darkest secrets. Imagine a landscape where time frays at the edges, where cause and effect lose their grip, and reality itself seems to ripple and falter. This is no ordinary puzzle, it is a fracture in the fabric of existence, a cosmic crucible where the familiar rules of physics are undone and something else, something stranger, takes hold. One particularly haunting possibility emerges from these depths, that black holes are not mere endpoints but gateways to other realities, a twisted form of cosmic recycling where matter and information might escape obliteration by slipping through unseen conduits. Some theorists propose that inside a black hole, the crushing gravitational forces might tunnel through spacetime, connecting to entirely separate universes or dimensions. These are not just idle speculations but ideas grounded in the mathematics of wormholes, a concept that bends not only space but our understanding of the universe's very architecture. Could black holes be the universe's secret passageways, portals that shatter the permanence of death and destruction, hinting at a multiverse where existence unfurls in unexpected and unfathomable ways? Yet, the implications stretch even further, into what might be called the paradox of identity. If information isn't destroyed but transformed or relocated beyond our reach, what does that say about the continuity of reality itself? The principle that nothing is lost, that every particle's state is preserved, confronts a sobering truth. In the presence of a black hole, our conventional notions of individuality and permanence dissolve. The very fabric of identity might be rewoven on scales so vast and so intricate that they challenge the notion of a coherent, unified self. In this cosmic theater, the boundary between existence and oblivion becomes perilously thin, and the mysterious endpoint of a black hole could be less a conclusion than a radical metamorphosis. Even more unsettling is the prospect that black holes might be arenas where quantum effects and gravity engage in a relentless clash without reconciliation. Here, the known laws falter and a new, unknown physics waits to be discovered, one that may rewrite our understanding of reality's most basic elements. Imagine a scenario in which the interior of a black hole holds a chaotic storm of microscopic structures so exotic and ephemeral that they defy measurement, altering space and time in ways that escape not only observation but definition. These quantum gravitational phenomena could be the key to unlocking a deeper layer of the cosmos, a realm where space and time themselves emerge from more fundamental invisible threads. It is a tantalizing thought that within black holes lie the building blocks of a new physics yet to be conceived, an entirely different game of nature played on an unfathomable cosmic board. In this context, black holes become more than astrophysical curiosities, they evolve into symbols of profound uncertainty, shimmering enigmas at the frontier of human knowledge. Their existence demands we confront daunting questions about the limitations of scientific inquiry. What if the universe harbors secrets forever beyond the reach of observation, encoded in the inscrutable depths of these gravitational abysses? What if the darkness at a black hole's core is darkness not only of light but of comprehension, a veil that no theory, no matter how elegant, can fully pierce? And yet, it is in facing these profound unknowns that the story of black holes takes on a deeply human dimension. They challenge us to embrace humility, to recognize the provisional nature of our most cherished laws and the vastness of what remains unconceived. They provoke a meditation on the fragility of certainty and the power of mystery to expand rather than confine our imagination. Here, on the shadowy edge of the incomprehensible, lies an invitation to explore not only the cosmos but the very processes by which we seek to understand it. As black holes stretch the limits of reason, they encourage a new openness, a readiness to entertain the unthinkable and to dwell in the profound ambiguity where science and wonder entwine. The dark possibilities black holes present are not just scientific challenges, they are existential provocations. They insinuate that reality may be more fluid, more layered, and more paradoxical than the neat frameworks we construct to explain it. In their silent depths, black holes whisper of a cosmos that is less a fixed order and more a sprawling mystery, woven from threads of chaos, chance, and transformation. It is a mystery that calls us beyond the edge of known physics and into a realm where questions multiply with no guarantee of resolution, where the journey itself becomes the ultimate revelation. As we stand at this horizon of understanding, black holes compel us to look beyond the certainty of equations and the clarity of observation into the wild terrain of possibility. In the deep shadows where physics breaks, they do not close a chapter but open a doorway into a universe not fully grasped, a story not yet fully told. In this silence and this void, we find the profound echo of our own quest for meaning in a cosmos that is at once stranger and more beautiful than we dared imagine. The story of black holes is not simply one of collapse and invisibility, it is a narrative that challenges the very tools we rely on to comprehend existence. They are cosmic paradoxes, places where time warps and space itself twists into shapes that defy our everyday experience. What makes black holes so enthralling is that they unmask the fragility of the laws we consider absolute, the laws that have guided centuries of scientific progress suddenly unravel before our eyes. Yet, within this unraveling is a deeper truth. it reveals the edges of human knowledge, inviting us not to despair but to marvel at the vast unknown still waiting to be illuminated. Imagine standing face to face with a black hole, not as a distant point of light swallowed by telescopes, but as an actual threshold that shatters the fabric of reality as we know it. Here, the concepts that seem eternal, causality, conservation, the predictability of natural laws, begin to falter. It is a moment that humbles even the brightest minds, a stark reminder that the universe is a far more intricate tapestry than any singular theory can capture. Yet this fracture is not a failure, rather, it is the universe's invitation to expand the boundaries of scientific imagination. To venture beyond the elegant equations of Einstein's spacetime and to embrace a new paradigm where gravity and quantum mechanics may finally reconcile their long-standing discord. What if, within these enigmatic singularities, the universe holds memories not just of matter and energy, but of the very genesis of existence itself? Some theorists suggest that black holes may serve as bridges to alternative realities or residues of cosmic histories that defy linear time. This perspective transforms black holes from mere voids into archives of cosmic secrets, repositories of information encoded in ways that challenge our current understanding of entropy and information loss. Such ideas hint at a cosmos that is less a mechanical clockwork and more an intricate, self-referential system, one where each breakdown of known physics gestures toward deeper layers yet to be discovered. In this contemplation, our place in the cosmos feels both infinitesimal and profoundly connected. Black holes teach us about the limits of certainty and the persistence of mystery. They remind us that knowledge is not a fixed destination but an ongoing expedition into the unknown, often marked by paradoxes rather than neat resolutions. The discomfort they inspire springs from their call to reconsider not just what we know, but how we know it, questioning the frameworks and assumptions embedded deep within our scientific worldview. Ultimately, the paradoxes of black holes mirror the paradoxes of human curiosity itself, restless, insatiable, and unafraid to peer into the void. They beckon us to embrace uncertainty as the fertile ground where new insights grow and to cultivate a scientific humility that welcomes what cannot yet be explained. In the silent gravity wells where physics breaks down, we find an opening to a grander narrative, one that transcends disciplines, inviting philosophers, physicists, and dreamers alike to wrestle with the profound questions of reality. As we reflect on what it means that black holes disrupt the laws of physics, we also reflect on the nature of knowledge and existence. They ask of us a daring leap, an acceptance that the cosmos might always hold mysteries that resist simplification. And in that resistance lies the exquisite beauty of discovery, a reminder that the universe does not surrender its secrets easily, but when it does, the revelations transform not only our understanding of the stars, but our understanding of ourselves. In the end, black holes are not the end of physics, they are its most luminous frontier. They offer a testament to the power of inquiry to transcend limits and a beckoning toward a future where what seems impossible today may become the foundation of tomorrow's understanding. As the cosmos continues to evolve, so too does our quest, a journey driven by wonder, propelled by mystery, and anchored in the profound realization that the universe's greatest secrets are still waiting to be unveiled. Imagine for a moment stepping into a world where time itself begins to unravel, and space folds into shapes that defy intuition. Such is the realm of black holes, regions so dense and powerful that the familiar fabric of reality is stretched beyond recognition. Yet beneath this cosmic enigma lies a deeper story, one where the laws of physics, as sturdy and reliable as they seem, no longer hold their sway. Black holes expose more than just gravity's might, they expose the fissures in the very language we use to describe the universe. Consider what happens as matter spirals toward the singularity, the heart of a black hole. Classical physics, particularly Einstein's theory of general relativity, predicts that this point is one of infinite density and zero volume, a place where gravitational pull crushes everything into an unfathomable point. But infinity is a concept outside normal experience. it signals the fraying edges of our theories. In a laboratory analogy, it's as though we took a perfectly smooth sheet of fabric to represent spacetime and tried folding it so tightly that the fibers tore. That tear is the singularity, a disruption not only of space and time but of the scientific framework itself. What makes this breakdown even more profound is how it forces us to rethink the interplay between the universe's two great pillars of physics, general relativity and quantum mechanics. At the cosmic scale, Einstein's equations have successfully described the warping of spacetime and the dynamics around massive bodies like black holes. Yet quantum theory governs the incredibly small, the behavior of particles and fields that make up the fabric of reality at the tiniest scales. These two frameworks, each stunningly accurate within their realms, collide inside black holes. This means that the singularity is not just a point of physical destruction but a point of conceptual collision, where our understanding crumbles. Take into account the event horizon, the threshold beyond which nothing, not even light, escapes. The event horizon is not just a boundary in space but a boundary in knowledge itself. Physically, it hides the singularity from view, but philosophically, it veils the very nature of reality behind a cosmic curtain. Recent theoretical work challenges the firmness of this horizon, suggesting it might be less a fixed boundary and more a dynamic, shifting region where information is not necessarily lost but transformed in surprising ways. This has deep implications for entropy, a measure of disorder in information, and hints at new principles we have yet to fully grasp. One particularly evocative modern proposal involves holography, where the three-dimensional reality inside a black hole's volume might be encoded on its two-dimensional event horizon, much like a hologram encodes a 3D image on a flat surface. If this is true, it suggests the universe may operate on principles profoundly different from those we've assumed. Space itself might be an emergent property, arising from more fundamental informational elements beyond space and time. The implications ripple outward. What we perceive as physical reality could be akin to a shadow cast by deeper quantum codes etched on cosmic horizons. Moreover, black holes introduce mind-bending puzzles about information conservation. Physics has long held that information cannot simply vanish, yet the classical view of black holes implies swallowed matter, and its encoded information is lost forever. This contradiction has given rise to intense debate, culminating in what's called the black hole information paradox, a puzzle that continues to fuel some of the most cutting-edge research today. As scientists probe the paradox, they are pushed toward radical ideas. Could the fabric of reality be fundamentally tied to quantum entanglement and information flow? Is spacetime itself woven from threads of entangled particles, unraveling inside black holes only to be rewoven anew at the quantum frontier? Contemplating black holes also forces us to reconsider causality, the flow of cause and effect. Inside these gravitational crucibles, traditional causality blurs. The inner workings of a black hole may distort or even invert time sequences, making the future and past less distinct. Such possibilities open tantalizing doors for new physics, but they also challenge the very logic that underpins our understanding of the universe. In this liminal space, where cause and effect might lose footing, established rules yield to yet undiscovered principles, awaiting the creative spark of future ideas. Astrophysically, the behavior of black holes injects profound consequences into cosmic evolution. The powerful jets of energy emitted, the gravitational waves rippling through space from black hole mergers, and the role these objects play in galaxy formation all point to black holes as agents of cosmic change, perhaps nature's alchemists, transforming the structure and destiny of the universe. Yet behind these grand manifestations lies the whisper of broken physics, signaling gaps in our understanding that make black holes less endpoints and more beginnings of new scientific voyages. From a philosophical stance, black holes fracture the neat boundary between observer and observed. Since no information escapes from inside the event horizon, what happens within is forever hidden, beyond even the reach of imagination rooted in empirical data. This challenges the principle of objectivity central to scientific inquiry. The realm inside a black hole merges into the unknown, reminding us that not all reality is accessible and that some phenomena force a reckoning with the limits of observation and measurement themselves. Above all, the real scientific weight of why black holes break physics is their invitation to rethink the universe as a living puzzle, one where contradictions are not failures but clues. They beckon us to transcend comfort zones of established knowledge, journeying toward theories yet unnamed, where gravity, quantum mystery, information, and entropy knit together in unexpected harmony. They are cosmic signposts, marking the frontier of human understanding and pointing toward a future in which the breakdown of physics inside black holes blossoms into a new physics of unparalleled depth. In this mysterious convergence of space and time, collapse and creation, order and chaos, black holes break physics, not to end it, but to fracture the way forward. They transform our scientific quest from one of certainty to one of endless possibility, where each shadow thrown by their darkness illuminates a deeper facet of the universe's profound and awe-inspiring complexity. Beyond the enigmas of observation and the boundaries of known laws, black holes summon us to contemplate something far more intimate, the nature of time itself and how it threads through our consciousness. Time, long considered the immutable river flowing steadily forward, loses its familiar shape in these celestial abysses. Inside a black hole, time warps and contorts so drastically that the linearity we depend on, moments folding into memories, events leading into futures, can dissolve into an indistinguishable, tangled knot. Imagine a clock whose hands are drawn to a point infinitely small, where every second stretches into eternity, and yet all moments converge into an instantaneous singularity. This is not a mere abstraction, but a profound prompt to reconsider how time may arise, flow, or even exist. What if time, as we perceive it, is not a universal backdrop but a delicate construct emerging from the interplay of space, matter, and perhaps consciousness itself? Black holes, by violating the usual rules of spacetime, may hint that time's arrow is not fundamental but contingent, a product of more primal, underlying processes that remain utterly hidden from us. This challenges us to ask, do black holes hold the key to a deeper dimension of reality where time unspools differently or ceases altogether? Could the breakdown of physics inside these cosmic prisons reflect a realm where past, present, and future amalgamate into an eternal now, a state alien to everyday experience but integral to the universe's heartbeat? This line of thought nudges us to consider the relationship between black holes and consciousness, an idea often relegated to philosophy but increasingly entering the dialogue of physics. Our subjective awareness is fundamentally tied to time's flow, to a sequence of experiences that give the self its continuity. If inside black holes time loses coherence, what does that imply about the survival of identity, if identity even matters beyond the event horizon? Might these regions be arenas where traditional notions of self and observer fragment, challenging the very idea that consciousness is rooted solely in physical continuity? Perhaps black holes symbolize not only a rupture in physical law but a rift in the fabric of experience, highlighting how deeply our sense of meaning is intertwined with temporal order. From a human perspective, black holes compel a confrontation with finitude and impermanence on scales that dwarf any earthly analogy. We measure our lives by moments, memories, and projected tomorrows, yet these cosmic enigmas embody extremes where duration and existence collapse into singular points. Therein lies their haunting invitation, to embrace uncertainty, to find meaning not just in what is observed and measured but in the profound mystery of what eludes comprehension. Black holes, in their inscrutability, mirror the human condition, are grappling with the unknown territories of death, the limits of knowledge, and the question of what lies beyond perception. They are not merely objects of astrophysical inquiry but metaphors for the psychological and existential enigmas that haunt us all. Moreover, the paradoxes birthed by black holes may serve as metaphors for the universe's deeper unity, a unity that includes contradictions and paradoxes not as failures but as signals of integration at a higher level of understanding. In the breakdown of classical causality and the entanglement of spacetime itself, we see a landscape where opposites coalesce, certainty dissolves into ambiguity, individuality melds into universality, and beginnings entwine with endings. This suggests that the universe's fabric might be woven from patterns of revelation emerging through breakdowns, where each shattering of established order clears the way for more profound, richer syntheses of truth. In this sense, black holes invite us not only to rethink physics but also to reimagine the human quest for meaning in the cosmos. They ask that we expand the scope of wonder and humility, acknowledging that some mysteries are intrinsic to existence itself, and that progress may lie not in conquering the unknown, but in learning to dwell within it. They remind us that the ultimate frontiers of science lie entwined with philosophy, spirituality, and the awe that propels us beyond the familiar. Black holes are not just cosmic anomalies, they are crucibles for new ways of seeing, challenging us to reweave the narratives of reality, time, and consciousness into patterns that transcend conventional limits. In allowing physics to break, black holes do not render knowledge obsolete, they elevate it, transforming the pursuit of understanding into an ongoing odyssey where the horizon continually recedes. This is a journey in which the absence of absolute answers becomes fertile ground for questions that deepen our engagement with the universe and with ourselves. To confront black holes is to face the raw essence of mystery itself, a reminder that beyond calculation and prediction lies the profound invitation to marvel, to imagine, and ultimately to evolve in our grasp of what it truly means to exist. Step closer now, into the shadowy periphery where not even light dares linger, where the very architecture of reality begins to wither and rewrite itself beneath the sheer gravity of unseen forces. Here, black holes become more than mere cosmic curiosities, they stand as gateways to the unknown, forcing us to reckon with the dissonance between our greatest scientific frameworks. The fascinating tension lies in this: black holes do not simply bend the rules of physics, they fracture them. To grasp why this shattering occurs, consider the phenomenon known as the singularity at a black hole's core. Unlike anything known in daily experience, singularities represent points where density spirals to infinite values, and spacetime curvature grows without bound. Yet infinity, in the physical cosmos, is a perilous concept. It signals where our cherished equations, like Einstein's general relativity, stall and break down, leaving us without a reliable map to proceed. Here, gravity is so magnified that it appears to swallow not just matter, but even the laws governing matter. To illustrate, imagine a perfectly smooth sheet, a metaphor for our understanding of spacetime. Until now, physics has described this sheet as flexible yet unbroken, reacting predictably to mass and energy. But near a singularity, this fabric does something unprecedented: it tears. The singularity is not merely a pit but a rupture, a location where familiar coordinates of space and time lose meaning, collapsing the very scaffolding that holds our physical intuition intact. Adding to this enigma are thought experiments like the firewall paradox, which challenge foundational principles such as the equivalence principle, one of the pillars of general relativity. The paradox suggests that a hypothetical observer crossing a black hole's event horizon would encounter ultra-high energy phenomena, contradicting the idea that crossing this boundary should be uneventful. This is more than a paradoxical curiosity, it exemplifies the clash between gravity's classical nature and quantum mechanics. If the two cannot be reconciled here, it calls into question the completeness of our understanding. Until recently, one dominant approach was to see black holes as information destroyers. Classical physics suggested that anything swallowed by a black hole, including the quantum information about its state, vanished irretrievably. However, this leads to a profound conflict with quantum theory's insistence that information cannot be destroyed, an imperative enshrined in the quantum mechanical principle of unitarity. The resolution of this information paradox represents one of the most profound intellectual battlegrounds in modern physics. Emerging from this intellectual fog are bold ideas from the cutting edge of theoretical physics. One contender is the notion that black holes obey a kind of holography. Everything occurring inside them might be encoded on their event horizon, a two-dimensional boundary delineating the unknown. This holographic principle radically alters our perception, suggesting that the universe itself could operate like an expansive cosmic projection, where information is conserved in an unexpected fashion. Such hypotheses challenge the classical three-dimensional worldview, compelling us to entertain the possibility that our spatial intuition might be incomplete or constrained by hidden dimensions. Another striking implication of black holes breaking physics involves the role of entanglement, the spooky action at a distance that so baffled even Einstein. Recent studies propose that entanglement might weave together different regions of spacetime, meaning that the very connectivity of space, and possibly time itself, could arise from a fundamental quantum phenomenon. Under this lens, black holes become laboratories where the quantum and geometric facets of reality knit together in mystifying ways. But what does this mean for our perception of reality beyond the scientific abstract? If the cosmos harbors regions where traditional physics fails, it invites a radical reassessment of the boundaries of knowledge. Black holes teach us humility, urging us to embrace mystery not as a failure but as an intrinsic facet of discovery. In confronting these cosmic enigmas, we are reminded that the universe is not a static collection of facts but a dynamic, evolving narrative, a story that unfolds with each question we dare to ask. The repercussions extend further still. If the laws as we know them falter near black holes, it beckons the tantalizing possibility of new physics, phenomena that might underpin a theory of everything. Could understanding black holes hold the key to unifying gravity with quantum mechanics, two grand theories that, for decades, have stood apart? This union promises not only to rewrite textbooks but to redefine our grasp of existence itself. Yet even as we chase these enigmas, black holes offer an emotional resonance as well. They symbolize the limits of our reach, the boundary between what is known and what forever eludes our grasp. This existential edge sparks a profound curiosity imbued with wonder and a touch of unease, reminding us that the universe is as vast in mystery as it is in expanse. In the quiet vastness beyond the event horizon, where certainty dissolves into paradox, black holes whisper their secrets. They challenge us to find beauty in breakdown, to seek knowledge amidst contradiction, and to journey ever onward toward truths that may forever shimmer just beyond the horizon of comprehension. Imagine standing at the threshold of a vast canyon, its depths cloaked in shadows that even the brightest torch cannot penetrate. Black holes, in many ways, are the cosmic equivalent of this abyss, but their depths twist and warp not only space but time itself. They invite us to confront a profound dilemma that goes beyond equations and astrophysics, a dilemma threaded through the very fabric of reality and consciousness. How do we reconcile the tangible, measured universe we inhabit with the intangible, almost poetic mysteries black holes expose? Time, as we experience it, flows inexorably forward. It structures our lives, our memories, and our sense of self. We often think of it as a steadfast river, a universal metronome ticking away uniformly for all observers. But near a black hole, this rhythm falters. Time dilates and contorts until it seemingly stands still at the event horizon, and deeper into the singularity, it's believed to collapse into a paradoxical void where traditional notions of before and after lose meaning. This shattering of temporal order raises unsettling questions. If time is not absolute, then what does it mean for our experience of reality, our memories, our very identity that depends on a chronological sequence? Consider the phenomenon of gravitational time dilation, where someone venturing close to a black hole could return to find that years, centuries, perhaps millennia, had elapsed for those they left behind. This creates an eerie disjunction not just between observers, but between lived realities. It beckons us to rethink consciousness itself, not merely as a progression through time but as a puzzle entwined with the architecture of spacetime. Could consciousness be tethered to the universe's geometric tapestry in ways we have yet to grasp? Or might it be more fluid, able to transcend linear time, much like the signals and matter trapped in the black hole's grip seem to defy the future as we know it? In the quest to understand these enigmas, scientists have turned to concepts as exotic as they are captivating. The idea of holography, for instance, suggests that information swallowed by a black hole is not destroyed but encoded on its surface area, the event horizon, as a two-dimensional hologram containing the entire three-dimensional volume within. If true, this principle not only upends our understanding of spacetime but also hints at a universe where reality itself might blossom from an encoded skin, challenging our intuition about the solidity and separateness of matter in space. Are we inhabitants of a grand cosmic projection, where the line between fundamental and emergent blurs? The implications ripple beyond physics, stirring philosophical waters about the nature of existence. Moreover, black holes push us to confront what it means for reality to break down. Outside these cosmic giants, predictive precision reigns, experiments can be repeated, equations solved, and futures forecasted. Inside, chaos and uncertainty dominate, signaling cracks in the deterministic edifice that science has long relied upon. Is this a hint that reality, at its core, is not a clockwork machine but something richer, textured with randomness, probabilities, or perhaps something as elusive as consciousness itself? This pushes us to think about the boundaries between the objective world and the observer's mind, suggesting that our understanding of existence might forever hover at the intersection of physical law and metaphysical interpretation. Black holes, then, act not just as astrophysical objects but as existential mirrors reflecting profound truths about limitation and potential. They force us to grapple with the fragility of human knowledge and the mysteries sealed within the universe at its most extreme. As we peer deeper into these cosmic abysses, we are reminded that the quest for understanding is as much an inward journey as it is an outward exploration. Each step forward dismantles familiar certainties and leaves us with shimmering questions about time's flow, the essence of consciousness, and the boundaries that define reality itself. In the face of such unknowns, black holes teach us an alternative mode of being, one that embraces uncertainty not as a void but as a fertile ground for wonder. They invite us to become cosmic explorers not only of distant galaxies but of the inner landscapes of thought and perception. In this light, the breaking of physics near black holes is less a failure and more a profound invitation. An invitation to transcend traditional modes of knowing, to engage with a universe far more enigmatic, layered, and alive than we have dared imagine. It is a call to weave together the threads of science, philosophy, and consciousness in a tapestry as infinite and mysterious as the dark depths themselves. Thus, the story of black holes is not merely about where physics stumbles. It is about where humanity begins anew, standing at the edge of comprehension, poised to reimagine reality, to redefine existence, and to rediscover ourselves reflected in the cosmic shadows that both conceal and reveal the deepest mysteries of the universe.